So Rishi is a second year student, MDes student at the Interaction Design program at IDC School of Design, IIT Bombay. And his presentation title today is towards accessible spatial audio interfaces on screen readers, concurrent speech, and the auditory torch. Am I right, Rishi?
Yeah, don't worry, I'll get to it. Yeah. I am audible, right?
Yes.
Cool. So I'll leave the video on for now, but in case the internet drops, I'll probably switch that off. One sec. Can you tell me if the screen is visible now, the presentation?
Yes, Rishi.
All right, great. Okay, so good evening, everyone, depending on which time zone you are in. But so my name is Rishi, and I will be spending the next 20 minutes or so talking about work that I've been doing over the last 6 to 7 months in the space of accessibility and specifically non-visual access of interfaces. So for everyone who's listening in, if you could just open this link up in your own browsers, that would be useful because I've added a lot of accompanying audio files and a few other resources onto the page. It will kind of make the entire presentation a bit more smooth. So it's rishivanukuru.com/torch. And
can you share the link in the chat? So
that would actually be easier. One second. So that's the link that will open a web page with resources for this presentation. So, and then also the blue triangle in the bottom left, that's an indication that there is a corresponding resource on that web page. So whenever you see that, feel free to alternate to that web page and listen to their corresponding audio files. But yeah. One second. Cool, so my slides are still visible, right? Okay.
Yeah.
Yes.
Proceed then. So what is this about? So this is an ongoing project, again, on accessibility for people with visual impairments. It began in the July of last year, and I'm still working on it, though in a different form. The bulk of the work that I'll be talking about today was done last semester under the guidance of Professor Aniruddha Joshi. And more recently, I've been working on a branch of that project with Professor Jayesh Pillai, who's also at IDC. And as Prachi mentioned in her presentation, this is part of the work that we'll be hopefully presenting virtually at CHI later next month. So for today, I plan to cover these steps. I'll begin by a quick overview of the background and the problem that I'm trying to address in this project. Then I will look at 4 modules that make up the CHI 2020 paper. The paper and the poster can be found at the companion page, so feel free to refer to that whenever you have the time. But I'll be talking about what this project and what the research problem that I'm trying to address is. I will discuss the process of designing the experiment, designing the apparatus, and finally executing the experiment, a pilot run of it at least. And I will discuss the findings and next steps from the experiment. At the end, I'll also have a very quick discussion about current work on the idea of the auditory torch. But let's just jump into it. So as sighted users, most of us, I think, we have access to a wealth of visual information, and most digital interfaces, technology, content, the internet, all of it is meant to be accessed visually, and it's designed for that. What this means is that it's taking advantage of the fact that we have constant access to a wealth of visual information, and this access is simultaneous. We can quickly scan through a large screen, a large set of screens, and gain the information that we require. Screen readers are one of the most commonly used assistive technologies for people with visual impairments, and they use it to access the same content that we do visually. And the idea is that screen readers access the document object model of websites or the syntactic structure of an interface, and they are able to understand the structural information of a page and present it to visually impaired users. What this means is that there are lots of barriers to conventional access. So like a screen reader does not know nearly as much information as a sighted human does. And therefore, the 4 barriers that were defined in a work by Donker et al. Are classified into the pixel barrier, the mouse barrier, the graphics barrier, and the layout barrier. And there's a bit more information over here. But broadly, what this talks about is how images have a lot of information inherently in them, and it's difficult to both translate that into text and also to inherit for any program to just understand what the image says. Furthermore, we interact with technology through a variety of systems, and back when this paper released, the primary mode of interaction was the keyboard and the mouse. The keyboard is still accessible to visually impaired people, but the mouse is not, because the mouse relies on constant visual feedback, which they do not have. And finally, the layout barrier, which is kind of the focus of my work, is how interfaces themselves are arranged in a manner that has semantic function. And if this information is not available to visually impaired people, that makes their own access of these interfaces more difficult. Leaving aside the problems with screen readers, there are accessibility issues with the content and interfaces in themselves. And to some extent, that is being addressed by web content accessibility guidelines, where there are these expansive set of guidelines that are recommendations for developers to adhere to. But the problem is that most websites really don't look at these guidelines, and even those that do, the guidelines themselves account for less than half of the accessibility issues faced by screen reader users. Despite all of this, visually impaired people still manage to find ways to access information and go about their daily tasks to the best of their abilities. They use various different strategies, some of which include heading navigation, which is quickly skimming the page and tabbing through the headings of a page to understand the layout, using visited links to narrow down the scope of their search, using the keyboard to simulate a mouse to explore the layout of a page, and also most directly keyword search. When people know exactly what they are on a web page for, they would be able to directly reach it by searching. For more general cases, heading navigation is an often used strategy, and that's also the focus of the project. I'll get to that in a bit. But this being the scenario, the exploratory technological question that we had was, what if screen readers could provide visually impaired users with both more auditory information as well as more information through audio? And why those two are different is something that I will come to over the course of this presentation. What this essentially means is that we looked at the technological capabilities of spatial audio, which is the ability to render digital sound to appear as if it were coming from the space around a listener. And this can happen either through headphones or through physical speaker setups. We chose headphones because they were more accessible and much easier to work with from a developer point of view. By more auditory information, I mean the idea of concurrent speech, parallel speech as an alternate. Like it could also be called parallel speech, the idea of listening to multiple streams of speech at the same time. More information through audio can be conveyed by the spatialness of the information, and that's addressed in the auditory torch part of things. The main focus of this presentation is concurrent speech and screen readers. So jumping back, like I mentioned, heading navigation is an often used strategy by visually impaired users. But this also has its limitations and its difficulties, especially on pages with lots of information. It can be really time consuming. And there are a number of cases where you can't just access information through keyword search. For example, if you're on a news website and if you want to look up information about cricket, not every headline, not every searchable item on that webpage would have the word cricket in it. And there's only so many keywords you can search for before it becomes difficult to actually access the particular headline you want. And therefore, combining this problem with the exploratory question, a more specific question would be, what if screen readers could allow for users to listen to more auditory information, such as, say, headlines, but two at a time, with the sounds themselves being spatially separated, perhaps being heard from the left and the right simultaneously. This is based on the idea of concurrent speech, and more fundamentally, the cocktail party effect, which is this fairly researched idea that humans have the ability to focus on a particular stream of information, even when in environments where there are multiple sources of information. And the effect is named after a cocktail party, where even if you were surrounded by multiple conversations, you're still able to focus on the conversation of the person in front of you. So this work, I mean, this human ability has been tapped into by various researchers in the past. Most notably, Guerrero et al. In 2016, they looked at using concurrent speech and seeing how both sighted and visually impaired users can comprehend and make use of this information. So they looked at the variables that they considered were the number of concurrent speakers, the difference in their voice characteristics, which could be whether the pitch of the speakers were different, or the gender of the speakers were different, on a relevance scanning task. What relevance scanning means is the task involved the presentation of multiple news snippets, and the participants were asked to identify the snippet of relevance based on a prompt that was given to them before the experiment began. The configurations of the various speakers are here. I'm using a pointer. I'm not sure if everyone can see this, but the idea is that from a top view, in the case of two speakers, you would have sounds come from both the left and the right. 2 points to clarify, this is all simulated via headphones. And the speakers that I'm talking about over here are synthesized text-to-speech voices that are used by screen readers to convey information. So you could have two on either end on left and right. In the case of three speakers, you would have one in the front in addition to the two on the left and the right. And finally, in the four speaker configuration, there were four equal angular spaced in front of you. So yeah, like in short, this study showed that it was possible to comprehend up to two concurrent speakers simultaneously, and it was possible to identify the relevant source of information when listening to up to three concurrent speakers. And this seemed to be a good enough basis to see whether we could extend this mere comprehension to a more real world use case or a real world task that visually impaired people might attempt to do. So now we come to the research problem. So this was an exploratory project, but then we also wanted to focus on the quantitative aspects of things. So the way we defined this was, how might concurrent speech affect real world tasks using screen readers? And in particular, how would that affect the strategy of heading navigation? And before defining a research problem, as it were, we had to define what the variables we wanted to consider were, and what we would measure in our experiment whenever it was defined. So there are a number of things that you could consider. You could, like Guerrero did, consider the number of speakers and their voice characteristics. Alternatively, their speech rate, the speed of the text-to-speech speaker also matters, because that's something that visually impaired people often vary to complete tasks faster. You could look at the interactivity with concurrent speech. You could probably give them interface options to say change the volume of speakers. You could play around with the type of content. Headlines are short snippets of information that are self-contained. Not all content on the internet is like this. And also you could look at the input type. Currently, the experiments are all passive, but then you could also have users actively interacting with the concurrent speech. Again, this was meant just for additional context. This was as part of a 3 to 4 month project last semester. And therefore, we scoped it down to just looking at the same variables that Guerrero et al. Did, specifically the number of speakers and their voice characteristics. We looked at 1, 2, and 3 speaker configurations, 1 speaker configuration being the normal screen reader that people would be familiar with, and 2 and 3 would be configurations similar to that used by Guerrero. And we looked at voice characteristics, but only to the extent of whether people were listening to the same voice in all of the various spatial positions or different voices in all of the various spatial positions. So therefore, the research question ended up being, what is the effect of the number of concurrent speakers and voice characteristics on speed, error, comprehension, effort, and preference while performing heading navigation with screen readers? Having defined that, we then moved on to design an experiment. The two variables of number of speakers and voice differences led to 5 different configurations. 1 speaker, 2 speaker with the same voice, 2 speakers with different voices, 3 speaker with the same voice, 3 speaker with different voices. And the top view layouts are on the right of the screen. So that's for reference. The distances were all kept similar to that used by Guerrero. I'll come to the technical points in a little bit. So we looked at the task of heading navigation in a list of 12 headlines. And we chose 12 because this would allow users to cycle through these in both the would allow them to cycle through these while listening to them individually, in pairs and in triplets, without leaving any overhangs at the end. So they would always be in that condition. And we first started off by looking at the various tasks that people do when they're using heading navigation. They may be searching for a specific headline, say about the Maharashtra elections. They may be interested in a field, like in sports or in politics, and they may be looking at all of the news that are in that category, and that's called subset search over here. Or they may be just wanting to browse the headlines of the day. All of these behaviors lead to very different task goals and task performances. And to scope down the experiment, we decided to focus only on searching in a list, which seemed to be a direct extension of the work done by Guerrero. So we then, looking at a list of 12 headlines, we had to define a prompt that would encourage participants to search for items. We initially thought we would just use random keywords from the headlines and ask them to search for those keywords. but we realized that that would not really be very representative of how you might search for headlines normally. So we decided to instead have a more descriptive prompt that gives people a motivation to search for a particular headline without revealing any of the keywords in that particular headline. So for example, the text on the right of the screen over here gives one prompt, the answer to which was one particular headline about Sachin Tendulkar. Again, on the companion page, all of the headline lists that were used can be read whenever you have the time. So this was the task. We would ask them to search for a particular headline given a prompt in a list of 12 headlines while listening to it one headline at a time, two headlines at a time, or three headlines at a time. Hence, what we decided to do to keep the time of the experimental session short was to ensure that for each of the 5 configurations, we would have at least 2 time tasks, but 1 training task so that people get familiar with what they're listening to. Across users, we decided to counterbalance certain aspects of the thing. Okay, sorry. So we, in terms of the order, we fixed it to go incrementally from 1 speaker to 2 speaker to 3 speakers so that participants have the time to become familiar with this unfamiliar metaphor, something that they really would not have encountered as part of an interface function otherwise. However, across participants, the plan was to switch the order of the same and different presentation in order to balance out the effects so that we could clearly see whether the different voices had any benefit or harm when compared to the same voice configuration. The plan was to also counterbalance the lists coming back over here. Given this, we had 15 curated lists, and the same lists were used would be used across all participants, and we would counterbalance that to ensure that the same list would not cause an order effect within the same speaking category. Having designed all of that, we went about developing the apparatus. I'll go over this very quickly. We used Amazon Poly to synthesize the text-to-speech in an Indian accent for the main speaker, and also used 2 American accent voices. Past research in this field has often tried to manipulate the voice of a central speaker using very slightly more advanced speech synthesis algorithms. We attempted to do that. However, the process of modifying a central speaker, the one that we followed, seemed to be based on Western speakers, and it was yielding very unusual results with the Indian text-to-speech voice that we used, and therefore we discarded that approach. We stuck to readily available text-to-speech voices. The experiment application for both presenting the information, allowing people to browse through the lists, and recording task performance was built in Unity with a C# coding backend. And the spatial audio was rendered using Resonance Audio, which is an API provided by Google. In addition to all of this, we also thought it would be important to perhaps develop more full-fledged interface prototypes that would give participants an idea of what use spatial audio could be of in interfaces moving forward. So we developed very brief versions of an auditory carousel and an auditory torch. An auditory carousel is very similar to a visual carousel. So if you remember how, say, food applications or iTunes would have these cards where you know what the prominent card is, but you're also aware of what came before and what after. Imagine that, but for audio, where alternative sources are placed to the left and to the right, but also far away from you. So you are always aware of some amount of context. The auditory torch takes that but applies that principle to 2 dimensions, and I will come to that eventually. So we built out these for both phones and tablets, and the execution involved a session with various parts. I will probably go over this very quickly. So we had an introduction where we gave them more information about the experiment, and we also made sure that they signed verbally, or in the case of silent participants, normally the certificate of consent. There was initial data collection about the participants themselves, and then we went about doing the task, the various 15 tasks across all 5 configurations. After these were done and the data was recorded, we asked all participants to rank each of these configurations on the basis of effort and preference. In some cases, we looked at confidence, but then we didn't use that measure moving forward. And then we had a discussion about how they went about using each of these configurations, comments about their preference, and what they thought about the demos of the prototypes. So this is how the setup looked like. Studies were either conducted within the IDC in the studio space or at the participants' homes. In this case, the participants were to the left and I was to the right. We then did a pilot study with 4 visually impaired participants and 4 sighted participants to both understand the validity of the method and ensure that the experiment was sound in itself, and also to understand whether this as an approach was meaningful to take moving forward. We did collect, even in this pilot, the quantitative information about the time taken, errors, the responses from the participants, and also the qualitative comments. However, what I'll be discussing over the next few minutes is mainly the insights gained from the 4 visually impaired participants. There was quantitative information as indicated by the plot to your left, but that was not the focus of this pilot. Nor can you really make any claims about quantitative data on the basis of just 4 people. But the overall comments seemed to be skeptical and sort of like the participants were really not sure about what the use of concurrent speech would be. Some of the comments are to the right. They specifically pointed out that they did not really see how this would extend to other use cases beyond news headlines, and that this would potentially be very difficult in longer tasks. But all of that being said, there were a few interesting insights. It was noticed that different participants had very different listening strategies. Some of them tried to focus on a single stream particularly and not listen to any of the others, and then move from one stream to the other in a windowed manner, kind of depicted in this diagram. And then whenever they found a keyword, they would stick to that stream. The other participants also surprisingly were able to listen and keep track of all of the audio streams in search of keywords that matched the prompt. And whenever they found the prompt, they would tune back into that specific stream. And this act of tuning in and out involves both identifying voices and identifying content. And this became difficult because of 2 reasons, both because of the spatial orientation of the speakers and the effect of voices. In terms of spatial audio, the left and right positions were fairly easy to identify, but the frontal position was very difficult to disambiguate. And this is something that is a problem with spatial audio in general, and that's something that we'll have to think of addressing moving forward. But interestingly, the effect of voices was different across different participants. Instead of perceiving the voices as same or different, the factor of whether they were familiar with the voice or unfamiliar with the voice played a bigger role. For example, even if participants identified that one stream had a keyword, if the other stream had a voice that they were more familiar with, they found it harder to tune out of that. And this effect varied across various participants and depended on the particular text-to-speech voice that they used. And therefore, yeah, I'll get to that in a bit. But then one final insight was that when I did present the prototypes to them, they responded a bit better, a bit more positively to the prototypes. But given that they were unfinished, there were concerns raised about whether this is how it would be implemented in the real world. Interestingly, some participants, building upon the prototypes, could present alternative uses of concurrent speech, one of which was not to substitute screen readers, but rather to complement screen magnifiers for people with low vision instead. The limitations of the study that we ended up finding out were the fact that, yes, there were issues with the voices that were employed, the fact that different participants had different reactions to the voices, and also the fact that concurrent speech for headlines seemed to have an unclear purpose, and the motivation of the research was kind of unclear to the participants. The random variables that would be encountered are kind of depicted in this diagram over here, where you could have headlines of different length, and therefore while cycling through them in pairs or in triplets, there may be points where you only hear 1 or 2 headlines at a time. The keyword location keeps varying across different prompts and target lists, and even 20 users, as we initially thought, may not have been enough for a properly sound study moving forward. That being said, the project as a whole did yield interesting insights, and I have tried to implement them in some manner. One idea that we had initially was to redesign the experiment itself. And if we were to continue on the quantitative HCI path, we would, instead of comparing concurrent speech with each other, we would compare concurrent speech with faster speech. Faster speech is a lot more common. It's a lot more accepted as a feature. And I feel like the argument of comparing these two could be a lot more rational and a lot more grounded in a real use case. So an example of that would be to compare status quo of one speaker at 100% speed versus a slightly more common one speaker at 200% speed versus our configuration of 2 speakers at the same time at 100% speed. But this is something that we thought about, but I have not taken this forward. What I have taken forward is the exploration of the idea of an auditory torch. To me, this seemed like a particularly interesting interaction metaphor, one where, so in the manner in which we use torches to navigate through dark scenes, where we are aware of what's in the center, what's in the focus of the torch very clearly, and that fades away as the torch itself, the cone fades away. Similar to that, what if we allowed visually impaired people to use something similar for sound, where they could point or touch at a specific point on a touch screen and be aware of the sound coming from that layout position, but also be aware in slightly lesser ways of the information surrounding them. And the question that I'm trying to investigate over here is whether this helps them overcome the layout barrier and understand interfaces better. To that end, I'm currently reviewing works that, so I've identified two particularly important papers that both propose the idea of the auditory torch and build upon it. And I'm currently looking at all of the research works that have since built upon their work, which is about 90 odd papers in the span of 18 years. There probably will be a report in a day or two, which you can check on the companion page. But yeah, so if this were how accessibility research is today, this is how I see this project being positioned: a slight increment over concurrent speech research that's happened in the recent few years, and hopefully a slight increment towards the idea of the auditory torch itself. But yeah, that's all I have for today. I'd like to thank both Anirudh sir and Jayesh sir, Dr. Charidhar rather, for his feedback through the project, and everyone at IDC. Thank you. And sorry for the delay. I can take questions now.
If you stop sharing your screen, maybe we can see everybody.
Yeah, I am. Yeah.
Go ahead, Sayan.
Okay. Hi, Rishi.
Hi, Sayan.
Great work. Okay. So, I mean, do you have any plan to move forward with the torch design and those, or, I mean, putting into some conferences, targeting some conferences, your work further?
So yes, the plan was to present the literature review combined with a few initial prototypes in a user study to assets this year. And I've also been in touch with the mentors over there. However, something that I am kind of concerned about is how most of this work has so far been very technical and research oriented. And I've not really done enough user engagement at this point of time to see whether this is addressing a real problem. So I'd like to do that first before really targeting a conference, as it were.
Okay. Okay. No, I mean, actually, yeah. So I'm also a publicity chair this year. So yeah, I also would recommend you to submit to assets. But anyway, I mean, just for the information, Matt, maybe if you have going forward, I mean, if you think that you need to first develop the prototype a little bit, I mean, forward, and then you can look back to the studies and have some new studies to focus on the, I mean, future conference venues or something, then write the paper. That's fine enough. I mean, of course, maybe you can get more information I mean, from the mentors in assets. Yeah. That would be helpful for you. I mean, to submit to for future Kai or future assets, which is maybe 6 months from now or 1 year from now. Mm-hmm. So that'd be fine. I'm just, I mean, thinking about how to improve it, because definitely this kind of auditory torch would be finding the understanding the usability or the user experience, and you have maybe 1 or 2 studies. Maybe you have a first version of the torch interface, and then you have the study with the sighted people and also the blind, I mean, the visually impaired people, and then see that how I mean, these have been differentiated, what kind of interaction, what kind of I mean, usability, I mean, feedback you're getting from them, and then based on that you have the second version, and then you have a longitudinal study kind of, I mean, maybe you can ask them to use for 15 days or I mean 20 days, I mean, and then report their qualitative, I mean, feedbacks, or even understanding through your I mean, log as a quantitatively, and try to understand that how, I mean, they are getting into it, and how quickly they can learn, and what actually happening, I mean, with this, and how the differences are, I mean, in the cited and the, so then maybe you can have a full paper and structure, and then you can also saying that, okay, this kind of interaction, how it could be looking forward as a discussion part of the paper.
Yeah, I definitely see this as a longer project, and I would like to have a more working prototype as opposed to just an experimental application in place. But yeah, like your advice definitely makes
Yeah,
sense.
yeah. Anytime you can contact me. I mean, if you have questions on anything, I mean,
Sure thing.
that's interesting.
Yeah, thanks a lot.
Yeah, great. But I hope that you'll get present this year, Kai. I mean, I don't know what will happen. So let's see what SLC chairs decide for you guys
Yeah.
to have an online presentation or not.
Yeah.
Anyway, thanks. Great work.
Sure. Thanks a lot.
Okay.
Anyone else?
I have a question for you. This is Pancho.
Hi.
Hi. Interestingly, I would like to know, how is this different from what's being offered as an accessibility feature on your iPad or Android?
What? So there are two parts. Like, so
What's
you are asking about concurrent speech?
What's already available on the iPads or any mobile device, I guess, is you'll be able to touch any part of the screen, and depending on what lies underneath the touch, it gives you voice output. It will tell you what you're touching, right? And if you noticed very closely, for them to get the reference point, to know where exactly, whether they are touching the upper part of the screen or lower part of the screen or somewhere in the middle, the visually impaired usually have the four corners as their baseline. So they kind of use that, because otherwise you're going to have a huge space to like refer to, right? And of course, the pattern of hierarchy kind of is it's similar to how we think, but because we're able to see stuff, ours is more visual than spatial. So just wanted to know how what you're doing is different from what's already being offered.
Sure. So I will address the question for the two different ideas separately. So starting off with concurrent speech, which is the main part of the project, it would be quite similar to what current screen readers can do on desktops or tablets or phones. The difference would be the volume of audio information at the same time. So instead of, say, having to, so on a phone, for example, if you're navigating through a website, you visually impaired users often swipe to go to the next headline. Not all websites really support the full-fledged exploration that you were talking about. So for example, the idea would be to, instead of swiping and listening to one at a time, if they had the option to listen to two headlines at a time from coming from the left and the right, the question that we would have to explore is whether this would help them in any way. And that was the purpose of the initial experiment. That's how I see this being incrementally different over there. However, for the torch, I find it particularly compelling because of how, so as sighted individuals, when we look at any screen, we're not only aware of what we are focused on immediately, but also the surrounding information. We're very quickly able to build a mental image of what we're looking at. On the other hand, for visually impaired people, it's easier on mobile phones and tablets because of the touchscreen and the fact that you can physically explore the entire space. But say on websites on a desktop computer, it becomes a very intentional act of exploring the website in order to build that mental image. And I perceive the torch as a way of assisting that by giving people a constant set of information of the context around their point of focus, which currently isn't available.
Right. Having said that, see, on desktops, you might as well know the keyboard is primarily the single most important input devices for the visually impaired. Yeah. So, having said that, like I said, the information hierarchy is probably their it's the base to their understanding.
Yes.
On the topic about two voices coming at two different, if you're going to listen to two different tracks, if you look at a normal person talking to two different people, it'll ideally be on conversations which have already been started.
Yes.
So, I could jump between people and then continue a conversation. But if somebody is going to come with a new conversation He's going to, let's say you're already talking to a person and, he's telling me about something, and somebody else comes in, introduces himself. Now, I won't be able to jump to that. So it's similar to, because, his topic is different. I wouldn't even know what he's talking about, right? Unless all of a sudden he asked me, unless I know what he's going to ask me about, like, would you like to have some tea? Yeah, sure, right? So I already know what he's going to talk about or something like that. But if he's going to talk rocket science, for example, or even, is it your car that's parked outside? Even if he's going to ask me that, I have to hold this conversation, listen to him, and then, understand it, because I'm not expecting such a conversation to happen, so I don't get it. So similarly, when you have to, let's say, audio that's actually reading from two websites at the same time, if it's the second audio may not mean anything to me right now, because I'm not even sure if the content that's being played is similar. And for that to happen, the second website needs to be, there should be a environment. You should build an environment like that where the results that they give and what is being read is already based only on the search and not something, like every website when it opens up has a welcome line and talks about the structure they have and the menu and all that, right? So I guess unless we don't build something like possibly a browser by itself, which only reads the content directly, starting from the search word. Let's say I use my voice to ask for something, search for something, and possibly the first website is what I'm looking at or listening to, right? And the second website has content that's relevant to the search. Well, what happens is it should not read anything else but possibly the paragraph that it exists in, right? Because if it's not going to do that, then again, I'm lost. I'm like, I would rather shut it off and focus on this, right? The skimming kind of does the same thing. Your eye basically looks for similar terms or terms that you'd like to see around the search word, right? So it's not only looking for the search word alone. Your eye kind of tries to track all the words that are the paragraph to bring the relevance of what you're searching. So adds to the relevance. Perhaps that's what is maybe something that you could do with audio. But like I said, we need a complete new browser to be built, for example.
I completely agree that, like, for this to be something that can be demonstrated to users, it would have to be a lot more in terms of, like, there would have to be a lot more functions. But then I'll just quickly address something that you started off speaking about, the idea that it would be difficult for anyone to perceive two streams of speech simultaneously. Yes, I completely agree with that. But the rationale that we used when we were thinking about this was how, if you look at really expert screen reader users today, some visually impaired people are able to listen to websites being read to them at 400, 500, 600% of the normal speed of speech. This is something that they've built over many years of training, and it's a ability that you really don't have as a normal human being. The question that we then asked ourselves was, if instead of speeding up speech, what if whenever the decision was made, what if they had decided to present more speech at the same time? Would that have allowed for visually impaired users to learn the ability in a similar manner? That we don't have an answer to that, which is why we thought of exploring this question. But I understand it's not something that anyone can jump into and start using from the get-go. It will have to be a very learned skill through practice over months and years, perhaps.
Right. Very interesting. Very interesting. One last thing. Did you find anything very challenging when you were doing the study, or anything to do with this entire research?
Oh, yes. There was like a slide at the end that I skipped for time, but then the biggest difficulty for me was being able to say convey my research to visually impaired participants, and it was very difficult for me to really explain what the perceived value of this was. And I was always struggling with the fact that this seems like a very exploratory thing and it doesn't really solve a stated need at the moment. And the expectation from visually impaired people is that research focuses on the problems of today. So like I had this slight conflict between, is this project, is this exploratory nature of things something that people will be able to accept today? So it's less about, say, the execution of the project and more about my understanding of things. But that was something that I still am kind of dealing with. I'm trying to understand what the best way to go about this is, and whether I'm actually solving a real problem or I'm just like exploring technology for the technology's sake. So
explorations is where we've discovered. So I guess you'd have to definitely do that and definitely do pursue this. It's pretty interesting. Maybe next time a video about seeing these participants would really, bring down the amount of explaining that you might have to do. That kind of.
Sure, I'll try to put that in place.
Thank you so much.
Yeah, thank you.
So,
anyone else?
Thanks, Rishi.